I'm Professor Yi Zheng from Northeastern University. How much do we spend every year on air conditioning? In the US, the commercial sector alone spends $20 billion annually, accounting for about 15% of their electricity expenditures. Residential numbers are even higher, closing on $30 billion purely on cooling. Hotter climates and critical cooling industries like data centers and refrigeration trucks also have a greater AC use intensities. Besides the high cost, we're also harming the planet with air conditioning. Between the associated emissions, global warming feedback loop, and the rising heat waves, the need for a green cooling solution is obvious.
What about cooling without electricity with passive radiative cooling? By creating materials that combine high solar reflectance and high infrared emittance, we can achieve significant temperature drops inside of structures. Where typical roofing materials allow a lot of solar incidence to be absorbed and not a lot to be emitted, passive cooling roofing materials do the opposite. By reducing the heat in and maximizing the heat out, we can achieve cooling without any electricity use. Our cooling material is composed of hydroxyapatite, which boasts near perfect solar reflectance and infrared emittance, while also being biocompatible. In addition, its super hydrophobic surface resists degradation, and its fire retardants provide safety for infrastructure applications. We've already published multiple peer-reviewed papers and hold patent licensing authority for the technology. Our product creates value for customers by significantly reducing their associated AC costs. In hot climates and high cooling load applications, this reduction can be well over 15% of their current AC usage. In addition, carbon footprints are reduced, and cooling can be expanded to areas where AC is not always feasible. Competitors in this space are limited by their durability and lose cooling performance over time, while our self-cleaning, super hydrophobic surface prolongs lifetime and cooling abilities. Where competitors use toxic materials and complex fabrication methods, we use an environmentally friendly material that's compatible with industrialized techniques. And crucially, our cooling performance meets or exceeds the competitors. We've also received international recognition for our technology with a significant amount of commercial interest and existing research funding. As a small company, the Acorn grant will take us a long way. With this funding, we will integrate our cooling fibers within an industry-quality paint matrix, allowing for simple application on structures of any size. We will verify the cooling capabilities of the composite and begin field testing on small-scale structures to accurately benchmark the cooling power in various environmental conditions. About half of this grant will go towards our consulting partners 3M and Saliva Energy, who will provide manufacturing support, life cycle assessments, and integration guidance throughout our field testing. The remaining funding will be used for the raw materials and equipment required to synthesize our cooling materials at pilot scale, as well as the components and supplies needed for field testing in different climatic conditions.
Our team has both the technical expertise and the business aptitude to bring this product to market successfully. Thank you very much for your consideration.